Hey guys, so sorry about earlier. This is the lesson that you missed because the internet was so spotty. So we are going to talk about congruent angles. And we've kind of already talked about congruent angles because we talked about congruent segments. So let me screen share the iPad with you and we will hop right to it. Unable to connect. One moment. Oh, I know, I shut the Wi-Fi off. Sorry guys. It's painful watching me today, isn't it? Okay, here we go. So congruent angles. So if you remember back when we talked about congruent segments were segments that were the exact same length. And if you look at this picture below, these are two congruent segments that are the exact same length. And by formal definition, two objects are congruent if they are a perfect match. Example, two segments are congruent if one can be repositioned perfectly on top of the other so that their endpoints coincide. So essentially, you could take this green one. Oh, great. Now we're having problems with the pen. This is just never ending. So essentially you could take the green segment and you could place it on top of the blue segment and it would be exactly the same match. Everything about it is the same. Something else that you want to note is that right here, it's working now, yay. This is the symbol for congruent. So sometimes you won't see that they've written out congruent. Sometimes they will just use the symbol for congruence. We can also talk about congruence in the form of triangles. So if two triangles are congruent, one can be placed right on top of the other so that its vertices coincide. So that means if you were to put this green triangle right here directly on top of the blue one, every single piece of it would match up exactly perfectly. And so over here, they've written that ABC is congruent to PQR. That means that every single thing about them is going to be exactly the same. And so far we've talked about line segments and triangles. We can talk about this with angles as well. So what would have to be true for ABC and DEF to be congruent? You can pause and think about it for a second. I think that if we were to take this blue angle and draw it perfectly over the green one and everything about it was a perfect match, they'd be congruent. Another way we'd know they were congruent if this one was 30 degrees and this one was also 30 degrees. Or if this one was marked to say it was the same and had the same marking as this one, we would know that they were congruent. So as long as there's something to tell us that they're the same, we would know they are congruent. So talking about congruent angles, two angles are congruent if when overlapped, the sides of the angles coincide at the vertex of each angle. Well, what exactly does that mean? If you look at this picture, this angle right here is going to be the exact same as this angle right here, which we can note with little lines to show that they're the same. So the opening is the same, but it says not the sides in this example are not congruent because if you were to look at this side keeps going because it's a ray. And this side stops because it's line segments. That's why these two angles are not equal. They're not equal because one of them has longer sides than the other. They are congruent, which means that their actual angles are congruent. Okay? So in the perfect world, we would always write everything perfectly, but we're going to go back and kind of look at ways not to write things to kind of help us learn from that, okay? So two angles are congruent if and only if they have the same measure. If we look at both of these angles, they are both 35 degrees, so therefore they have the same measure. One thing that we noticed, just like the last picture, is that this has rays for sides, and this has line segments for sides. So these are not equal, okay? So let's kind of look through and see what's going on here. So this right here says the measures of ABC and the measures of RST are equal. Well, this measure is 35 degrees and this measure is also 35 degrees. Therefore, that is true. The measures are equal. So if we pop down here, that's the exact same statement. They're both 35 degrees, so that means that they are equal. Well, over here, it says 35 degrees is congruent to 35 degrees. That's not really the proper way of saying it because they are equal. Like 35 is the same number as 35. So you wouldn't put congruent that time. You would put equal. Okay. If we hop back up to the top, It says measure of angle ABC is 35 degrees. Anytime you're giving a number answer, you have to have measure written, which is why this is the incorrect answer because there's no measure written right there. And then lastly, we have angle ABC is congruent to RST. This is the correct way. They are not equal. They're not equal because this one extends way longer than this little one here, okay? Because these don't keep going, they just have dots at the end. That is why they are not equal. So continuing on to talk about this, one way to indicate that two angles have the same measure is to label them with the exact same variable. For instance, labeling both of these angles with an X indicates that they have the exact same measure. So X equals the measure of angle ABC, and it also equals the measure of DBA. So we know that the measure of ABC is X, and we know the measure of DBA is X. Well, that's the same thing, okay? Which makes them congruent. That doesn't mean their sides are the exact same length. That just means that their angles are the same. So this time they've chosen an X. They could have chosen an A if they wanted. They could have put like a little heart here, or like a line here. As long as you have the exact same thing inside both angles, that shows you that they are the same and that they are congruent. So another way to show that a pair of angles are congruent is to have a mark, the angle with an arch and a slash, which is what we have in this picture. So if you look right here, it's marked with an arch and a slash. And right here, it's marked with the exact same arc and the exact same slash. And that is how we know that they are congruent. Continuing on with this, a third way, I guess you could say, to make sure that these are congruent is by noting right here, these are marked exactly the same. Okay, when you have the same thing written inside the angle, that means that they are going to be the same. Fourth example here, they have two lines right here, and they also have two lines right here. That means that they are congruent. If the measures are the same, and you know that by the markings, then the angles have to be congruent. So right now, what I want you to do is I want you to pause this video, and I want you to take the knowledge check. And this is knowledge check 15 through 19, I believe. Let me see if I can get it pulled up. It is knowledge check 15 through 19. So you're taking congruent angles 15 through 19 knowledge check right now. Okay, congruent angles 15 through 19 knowledge check. So go ahead and pause until that's finished. And now I'm going to go over it.
Is angle B congruent to angle E? Well, angle B has an arc and a slash. Angle E also has an arc and a slash. So yes, these two angles are congruent.
Okay. If we look at question 16, oh, it's going to let me do it. Congruent angles blank have the same measure. Congruent angles will always have the same measure. Okay, that's just like a rule, and in order for them to be congruent, they're going to have the same measure. So they could both be 35, they could both have one arc, something like that, but they're going to have the same measure.
Angle A and angle B are congruent because they both have an arc and one slash. So they are congruent. A.
Oops. Kind of started over here. 1 second. Let's find where we were at. Okay. Back to question 18.
Angle E and angle F are, well, it cannot be determined. We don't know if they're congruent or not. There's no arcs, there's no slashes, there's no variables. There's nothing that would tell us whether or not the measurements of these two angles are equal. So the answer is C.
All right, question 19. Oh, okay, it's gonna let me do it. So it says C and D are congruent. Is that true or false? That would be false, and we know it's false because when we look over here, there are two, and when we look over here, there's only one. So therefore, they would not be congruent. Okay, so now we're gonna talk about angles and the angle addition postulate. Okay. So I'll give you a second to kind of digest this. We've talked about adjacent angles before, so this should be a review, so go ahead and read it and then we'll go over it. Okay, so adjacent angles are angles that are next to each other. And in order to qualify as angles that are next to each other, they have to have a common side, which in this case is right here. So if we really look at this, there's a lot of angles in this picture, but this angle that I'm currently outlining in green is adjacent to the angle that I'm outlining in blue. And the pink is the common side that they share. And so they are adjacent. Then we have the angle addition postulate. And I'm going to highlight these first before I go ahead and explain it. So I have AOB, which I'm going to highlight in this blue. And then I have AOC, which I'm going to highlight in orange. And I have COB right there. Okay? So that's kind of a bad color. Let me pick another color. Sorry, guys. So COB I'll do in pink. That's easier to see. Perfect. All right, so what it's saying essentially is the angle addition postulate states that the measures of two adjacent angles added together form the measure of the angle of their exterior. So in English, what that means to you guys is if you take that orange angle that is right here and you added it with the pink angle that is right here, so your orange one is here and your pink one is here. If you added both of those together, you would end up with AOB, which is the outside. So you can take the two pieces and add them to the whole. So for the angle addition postulate, part 1, C has to be in the interior of AOB, which in this case it is. So that says that if you take this green one, AOC, and you add it to this orange one, COB, you will end up with the total right here, which is in pink, okay? So basically you can take pieces and add them together. Part 2 of this is when C does not lie on AOB. But the thing we know here is that this is a straight line, and a straight line will always equal 180 degrees. So if you have two adjacent angles on a straight line, they are going to equal 180 degrees. Just like this. Okay? So an example of the angle addition postulate, I'm going to highlight these for you first. They give you PQS, which is in orange. And they give you SQR, which I've done in pink. And then they want you to find this. Well, if we took this orange and the pink and added them together, those two pieces are going to equal the whole. So 32 plus 26 gives you 58 degrees. So PQR is 58 degrees. They could have told us that PQR was 58. So we know the measure angle PQR is 58 degrees. They could have told you that and not given you this number. And you would have had to take 58 minus 26 and you'd find that orange angle. So you can do this various ways. So the angle addition postulate example, and this one's a bit more intense, so I'm going to color this first for you. So it says ANJ, and we'll highlight that in purple. ANJ is right here. And then it says that ANB. And sometimes they won't have the numbers written in the angles, so you'll have to put them in there, which is why it's important for you to be able to identify angles. And then we've got this right here, okay? Oh, sorry, I forgot to, let me go back and highlight this so it's easier. So now our job is to create an equation that works for this. So we can take the orange and the purple and add them together. So we can take 7x plus 11 plus 15x plus 24, and we can set it equal to that entire outside, which is 9x plus 100. And then from there, we want to combine like terms on the left-hand side. So we have 7x and 15x, which gives me 22x plus 35. And it's going to equal 9x plus 100. And we're going to continue solving for x. So we can subtract 9x minus 9x, and you end up with 13x minus 35 gives us 65. Okay? And divide this by 13, you end up with x is 5. So that's another way to look at the angle addition postulate. This time it only asks you for x, but if it asks you for more than x, all you do is take the x and plug it in. So you could say 7 times 5 plus 11, that gives me 46, right? So this one's 46. We can plug it into the next one, 15 times 5 plus 24, and that gives me 99. And I know automatically that this big green angle right here is going to be 145 because 99 plus 46 gives us 145. But if we didn't want to infer that, we could still plug it in. 9 times 5 plus 100 gives us 45. So it's important that anytime you find an angle, you can always plug it back in, okay? And that is your lesson for today. What I want you to do right now, and you do not take the knowledge check over this, okay? Do not take the knowledge check over this. I want to go over this with you in person one more time. So please do not take the knowledge check on this, okay? What I want to do is I want to share my other screen with you now. Because I want to make sure that you're not missing anything. So today in class, you should have done congruent angles 15 through 19. Should have already taken that. I also would like you to take a moment and look at the stream. The stream says that if you have not done these 3 knowledge checks, you need to do them as soon as possible because I'm going to go ahead and put grades in on Wednesday, okay? So if you have not done these, you need to do them. Where do you find them? All you do, this is the week that we're in right now. This is today's knowledge check. You just scroll down and they're all from last week, all 3 of these. So make sure you have taken all 3 of these, and if you have, then you're good to go, and I will see you on Friday.